Moving on to some more Further Pure 1 revision today, we're going to take a look at a very small kind of chapter within Further Pure 1, and it's a numerical methods chapter, but specifically using Simpson's rule. Now, this is only on the A-level exam, so if you're doing AS, you don't need to worry about this video. You won't be doing Simpson's rule. But if you're doing the full A-level, then you need to know how to use Simpson's rule. So what we've got here is a question where we've got to use 4 intervals to estimate this function here, ln of x over x. Now, Simpson's rule gives us an approximate answer for an integral. So we're integrating ln of x over x between 4 and 2 dx. Now, Simpson's rule, you need to know the formula, so this isn't given in your exam, so you need to know how to either derive it or just memorize it. I'd recommend just memorizing it. It's not particularly tricky at all. But the first thing you've got to do for Simpson's rule is work out your h. Now, h is the upper limit minus the lower limit. So 4 minus 2, so 4 minus 2, and then you divide that by how many intervals we need. So we're doing it with 4 intervals for this question, so we divide by 4. Okay, so 4 minus 2 is 2, divided by 4, which simplifies to 1 over 2, or 0.5. Okay, so that's our h. Now what we're going to do is we're going to set up a table of our x values and our y values. Okay, so my first x value starts at the lower limit, so 2, and then we go up with our h value. So we increase each one by 0.5. So my next one will be 2.5, my next one will be 3, our next one will be 3.5, and then we stop when we reach the upper limit, which has to be my next one, which is 4. Okay. Now all you need to do at this point is just sub your values in. So if you put 2 in here, so ln of 2 divided by 2, what will we get? So I'm not going to actually do all this work in here. I've already done it on a piece of paper. So here you'll get 0.3, 4, 6, 5, 7, so on and so on. So these will go on a bit longer, but just take it to a reasonable sense of accuracy here. So my next one will be 0.36652, 0.36620, running out of room a little bit, 0.35793, and then finally 0.34657. Okay. So we've got our y values. Now we actually need to apply the rule, so the formula. So we're integrating ln of x divided by x between 4 and 2 dx. Now this is going to be approximately equal to a third, so it's always a third, times by h. So my h in this question is 0.5, so it's a third times 0.5. We have a bracket, so it's very similar to the trapezium rule. So we multiply this by a bracket. Similar to the trapezium rule, we're going to have the first term and the last term, the endpoints. So I'm going to have 0.34657. And then I'll have my 0.34657 again at the end. We'll put it back in at the end. We add 4 lots of the odd terms, so 4 lots of the odd. Now your odd ones, if you're unsure how to work at the odd ones, this would be y0, this would be y1, y2, y3, and y4, for example, right? So that's how we know which one's odd. So if it helps, what I'd also think about this is even, odd, for example, like that, and even again. So what I'm going to do here is 4 lots of my odd terms. So my odd one here is 0.36652, and we've got this one here, this y3, this is an odd term as well, so 0.35793. Okay, there's no more odd terms, y1 and y3. The only even term we have is y2. Now y4 would be even as well, but because it's an endpoint, we don't include it. Now we do 2 lots of the even terms. So that's 2 lots of 0.36620, and then we add on the endpoint here at the end. Close that. Work this out on your calculator. So at this point, you just need to make sure you can actually type these on your calculator. you'll get 0.721. So 3 significant figures. Okay, and that's all you have to do for Simpson's rule. So it's very simple, very methodical though. Work out your h, like we did here. Write down your table of values. That's your next step. Remember, it goes even, odd, even, odd, even, depending on how many strips you have, or intervals, I should say. So your first one's y0, then y1, y2, y3, y4, and so on. So your first one's always y0. And then you always do a third times by h. Then multiply this by the endpoints. So 0.34657 plus 0.34657. And then we do 4 lots of the odd terms plus 2 lots of the even. And multiply that by a third of h. Okay, so it's as simple as that. But let's do another one just to see this illustrated again. Now this time we've been given a diagram to show it, but it doesn't really change anything. You've just kind of got to be aware of what your interval is for this question and what the integral limits are. So we write this down. We're integrating now the square root of cos x plus tan x dx. Now we're integrating this between x is equal to 0 and x equals to 1, like we're demonstrating here on this diagram. So my upper limit is 1, my lower limit is 0. And like any Simpson's rule question, we need to get our h first. So h is the upper limit minus the lower limit, 1 minus 0, divided by the number of intervals you want, which is 4. So 1 minus 0 is 1, divided by 4. H is 0.25. Okay, so that's our h. Now we need to do our table of values. So xi, yi, and remember we start at the lower limit. So the lower limit is 0. Our next one will be, because we're going up in quarters, it'll be 0.25. Our next one will be 0.5. Our next one will be 0.75. And then finally 1. Okay. Now all you need to do is sub this value, your x values, into your function here, f of x. So for example, it'd be cos 0 plus tan of 0, take the square root of that. So your first term will just be simply 1. Now keep putting these in. Obviously these will go on a lot longer, but 1.106, so on and so on. Again, mine's very, very scruffy. Make sure yours is neater. 0.5, this will give you 1.193, so on and so on. The next one, 1.290, so on and so on, and then finally 1.448 carries on as well. So that's your table of values. Now all we've got to do is the formula. So we're integrating square root of cos x plus tan x dx. So this is going to be approximately a third of h, which is 0.25. So a third times 0.25 multiplied by, remember, the endpoints. So put the first one there, that's 1, plus, I can't make me jump, plus 4 lots of your odd ones, y0, y1, y2, y3 and y4. So my odd ones are going to be y1 and y3. So 4 lots of 1.106 plus 1.290. Okay, we do 2 lots of the even. So that's going to be 2 lots of 1.193. Remember, we don't include this y4 here. It is even, but because it's the endpoint, we don't include it with the evens there. Close that bracket and then add on your endpoint, 1.448. Okay, put this on your calculator, and what you'll get is that the area A is going to be approximately 1.202. Okay, so that's our estimate there for the shaded area. And then part B is the 1 marker. It asks us to suggest how we could improve the approximation. So nice and easy, just how we can improve the approximation. Well, all we've got to do to improve it is just to increase the number of intervals. So increase the number of intervals. Okay, increase the number of intervals which this gives a better estimate. Okay, simply that's all you've got to say. So just we increase the number of intervals. Okay, so let's move on to the final question. Like I said, very brief video, just 3 quick questions. We've got another function here, f of x, which is x cosh x. Now we've got to use Simpson's rule. This time we're only 2 intervals. Now typically you'll only be ever normally asked to do 4. Sometimes you might be asked to do 6 or 8, but usually it's just 4. You might get the other one with 2, but obviously they won't go more than 4 really, because it just increases the time for working. And they want to test more that you actually understand the rule than being able to use your calculator. So we work out this last one. What we've got here is an integral between 2 and 1. X cosh x dx. So again, work out h, upper limit minus lower limit, divided by the number of strips, so divided by 2. So 2 minus 1 is 1, divided by 2. So we've got a h of 0.5 for this one. So now let's work out our table. It's going to be a nice small table. So we start at the lower limit, so 1. We're going up in terms of a half, so my next one will be 1.5. Final one will be 2. Plug in your x values into your formula here, so 1 times cosh of 1, and then do the same for 1.5 and 2. So if I do that, that'll be 1.5 for 308. 1.5, that'll be 3.52861. That's a 5. And then for 2, it'll be 7.52439. Okay, so we've got our table of values, and this is y0, y1, and y2. So technically for this one, we don't have any even terms here. We would have y2 and our y0, but because of the endpoints, we can't include them. So now, looking at the area, so the integral of x cosh x, well, that's just going to be simply approximately a third times h, which is 0.5. Your endpoints, so 1.5 for 308, plus 4 lots of the odd terms, which is just the middle y1 there, plus my endpoint again. We have no even terms, and that's simply all it is. Okay, plug all this in your calculator, and what you'll get is 3.8637. Okay, and there we have it. So that's this video done today. A very brief video just on Simpson's rule. I hope it's helped. If there's any comments, anything you want to ask, just please ask down below, and I'll try and get back as soon as I can.